Hey there, I think we are live now. Okay, let's wait for everyone to join. Let's wait for a while for some of my students to join. Those who have already joined, let's do it the streaming way. Write W in chat. We have a lot to do now. I request you guys to hurry up because we have to get started. That's great. Mr. Munib, Abdullah Khan, Omar Khan, World News. Who's this World News? Taha Zaman. Who is you, World News? Type your name. Mahad Ilahi. Okay. As soon as we get a decent viewership, we'll get started. Yeah, it's going to be live. It is going to be live. Okay. I think now it's time to get started with the stream. Arun Khan, walaikum salam. Okay, I think I got a decent viewership now. Let's begin. Okay, so this is the book I got. I have downloaded it from online. There were many websites available. So sometimes it's confusing, but this is the book which I found, and I think um, uh, it has like all the pages included because the last time someone sent me the book, it was I think probably around 120 pages were there, and the rest, the rest weren't there. So I had to download it again. And this book I searched online and I have found it um, quickly. Pretty that was like straightforward because it was already available on a website. I don't know how you guys didn't manage to get this. Anyways, so through this is a very an advanced version of the controller book because obviously it has a bit more than what was expected. It is having the I2C and SPI protocol as well. I hope you guys use it in near future. So let's get to the content first of all. Let me zoom it in. So you have to like you get started with 8051, you have first of all you have to learn what 8051 is about. um, so when you know the instructions, and obviously in the first go you're not going to you're not going to cover all the instructions in the first go. So you have to go step by step. Obviously, if you're familiar with electronics and stuff, and even digital logic design, you don't have to worry about the first few pages. You have to jump right into these instructions and IO ports. So after you know sorry for the delay. Um, After we mm, like study the instructions, we have to get into chapter number 4 right away, because this is the the chapter where we learn how to assess the ports, the individual pins. If you have the book open, I will request you to go to page 51. I think it's the page where you have all the information. No, it's not page 51, I guess. It's something else. Let's go for it. Yeah, so it's page 75, which has um, the chapter number 4. Uh, so over here, you can see all of the pins on the first page 76. It has all the pins for the controller, and so this is the on page number 77. I hope it's page 77. Yeah. So it's page 77. You can see the port 0, the details of port 0, like how to operate port 0, since I've already told you guys that port 0 is not having, it's an open drain. It's already mentioned over here as well. Let me fix this mic first of all. So it's already mentioned over there that it's a open drain, and it's um open drain is a term used for most chips, in the same way that open collector is used for TTL chips. I've already told you guys about this, the TTL and MMOS and CMOS and every, the type of chips that we have nowadays. So TTL chips have open collector, in the same way MOS chips have open drain. So it serves its own purpose. You have to make use of, if you want to make use of port 0, then you have to pull up the all of the lines, like just you can even pull one of the pins which we want to use in our case, but it's better to pull up all the lines, but in your kits which you guys have, all of the lines are already pulled high, so you don't have to worry about pulling up everything. um, so moving on, you can see a bit of program. Let's see what it does. Toggle all bits of port 0. So this program essentially toggles all the bits of port 0 after a delay. There is a small delay, the function we created in our first session. So and for it's all about port 0, and this is the port 1, the program for port 1. I've already written the program for LED toggle using assembly language. Um, so there is this port number 3, which this port actually serves a lot of other functions, which involves the use of UART, interrupts, and a bit of if you want to connect some external chips, then it also has its own special purpose pins, which we have to use it with those chips. Okay, so now I guess I'll have to get going, and we already covered all of this, nearly all of this. I've already included the link for the book in this description. So if you don't have the book for now, you can go to the description of this stream and download it from there. Um I've already included the link. I've uploaded it to the drive, and you can download it from there. Anyways, this is the program for a buzzer. When you press this switch, it toggles the state of the buzzer like real fast. So this thing like it's probably going around uh, anywhere from 4 megahertz to 6 megahertz. It's toggling the state of the buzzer, which create a buzzing sound. You can also do it with a speaker. So what we'll do in this session is we'll create a program you know which will toggle the uh, LED based on the you know the state of the push button. I will use a push button, and based on the state of the push button, the LED will be toggled. So let's get right into it. Let me open the um, Proteus and Keel terminal. First of all, let's get started with the Keel terminal. I think I can make it a little short. Let me do it if I can. Yeah, all of this. Okay, here we go. Well, now it's. I think it's probably going to fit right into the window, and how am I going to fit this in? It's a very tiresome job, fitting everything into the screen. I hope it works now. Yeah, it's better now. Okay. Yeah, so let's get right into it. And first of all, let me create a new program. Go to project, new microvision project, and right here, or maybe in documents, let me go to the yeah, this folder, because obviously we have already created it. Uh, Let me name this folder as button, and let's name this project as the button project, and let's get started. Let's create this project. Those who are following, they can write yeah, walaikum salam. Sorry, I wasn't looking at the chat. हारून खान, आपको बहुत टेंशन है इसकी पाकिस्तान के हालात की. आई होप कि आप बेहतर हो जाएं. हालात, सारी दुनिया के हालात बेहतर हो जाएं, सिर्फ पाकिस्तान के नहीं, सारी दुनिया के हो जाएं. ठीक है, आप खुश हैं? मैंने दुआ कर दी. अच्छा, ये हारून खान जो भी हैं मुझे बताएं फिर आप. ठीक है, आप मुझसे मिल लें, इज्तिमाई दुआ भी कर लेंगे. अच्छा, those who are following me, they can write W in the chat, so I get you guys are following. Write W in chat so I can see how many of you guys are following. कितने लोग फॉलो कर रहे हैं, कितने लोग यहाँ पे पहुँच गए इस स्टेप तक. W लिखो भाई. व्हाट द क्रिकेट, ये कौन है? नाम लिखो भाई अपना. प्रेजेंट सर. कौन है? ओके. ओके, सब फॉलो कर रहे हैं. ठीक है. ठीक है, जो नहीं फॉलो कर रहे उनके लिए मैं वेट कर रहा हूँ. ओके. हम्म. ओके, ये कौन है? टॉक्सिक अब्दुल्ला. प्लीज़ चेंज योर नेम. रिपीट करें? क्या रिपीट करूं भाई? टॉक्सिक अब्दुल्ला क्या रिपीट करूं? कैसे सेव करना था? यू कैन. ओके, लेट मी डू इट अगेन. Okay, you have to go over here, new new project, and let's name it as button. This is what you were talking about, Abdullah. I think there's another window which you guys cannot see, so that's why. Yeah, let me include the window. There is another window. Target one. Yeah, that's the window. I hope now you can see it. Okay, now you can see it. Great, great. So let's move. Let's go ahead. And okay, ठीक है इनके लिए थोड़ा वेट कर लेंगे. जब मुकम्मल हो जाए वेट तो बता दें मुझे. जल्दी बताएं. Sanaullah, please control. You know, it's a public platform. You don't get to bash others over here. um, I'll have to listen to everyone on this platform. Um, so now, like, you probably have to calm down. In class you can say whatever you get to say or you want to say, but over here it's about public platform. Anybody can text me anything. I have to be prepared, and I am prepared for any sort of things whatever come around. Whenever you're ready, please tell me so I can go ahead. Oh yeah, yeah, I forgot about this feature. Uh, Whenever you want to see something, you can always rewind in real time. Probably I think I have to go forward with it. Yeah. In search, you have to type 89C51 or any other control which you want to get started with or you want to write program for. You can select the controller, and in the description box you can see all of the details of the controller. Okay, great. Great. आपका वेट मुकम्मल हो गया. ठीक है. In description you can see all of the details, of the controller. The Let's get into some of the description, details. There are 32 IO lines. There You can make use of these lines. Essentially these are just ports. There are eight pins in a port, since it's an 8-bit controller. And there are four ports that are usable. 4 cross 8, it makes 32 IO lines. It was pretty easy for me to guess all of where all of the lines comes from. There are two timers involved, six interrupts. These are hardware interrupts, and two priority levels. I'll get into the detail of what interrupt is and what timer counter and priority levels are. Let's not worry about this for now. UART, there's just one UART. That's going to be difficult for us in the future. Three level program memory lock, 4 KB. You know, this was a thing people were uh, they always confuse flash memory and RAM. So flash memory is the memory where you write the program and you write the program to run. And the RAM, obviously many of you guys are familiar for if you have joined the stream. RAM is the place where a controller or a processor stores its temporary data. That's what a RAM is. After choosing your controller, you have to hit enter, and yes, you have to hit yes. It will create the um, project, and once created, there's some glitch with my window. Yeah, the glitch is gone now. Uh, you have to first of all create a file. You have to go over here and create a file. I was having a decent viewership, but now the viewership dropped. I don't know why, but people just they are coming and going. They're leaving the chat and just I think you guys are having fun. Okay, let's get into the creation of the files. So over here you have to add new item. Can you see it? Can you see the window? Let me see if you can. So I think it's not visible. Is it visible? Mm-hmm. Let me see. Oh, okay. Great, great, great. Okay, let me add a new file, and what I'll do here is that first of all let's create a file for assembly language, and essentially I'll name it button, since the project is about button. So it's easier for me to name. The naming convention in my case is much easier. um, and afterwards hit OK. I've already done that. Are you guys following? Okay. Okay. So over here the only thing now left is to you know uh, change the frequency 11.0592 and create a hex file. Okay. Zaman, thank you. Okay. Now what I'll have to do is now I'll have to write a program. So in this in this session over here, what I'll do is I'll create a program and I'll let you guys have some of the understanding of how the assembly language program works and how it's written, because obviously you guys have no idea how it worked when I was performing in the lab. So over here I'll briefly introduce you to the concept of how to understand a program. um where was I lost my program. Okay. Okay. So okay, I lost the file which I have made in the class. So now I'll get I'll start the program from scratch. I'll start to write it in assembly from scratch. So let's get let's get right into it. First of all, which what you have to do is you have to define the origin of the program, which is org0, or let write it this way, because you can also write it this way. Org00h or org0 would do the job. And the in the last you have to define end. So let's do it uh, beforehand, so I don't mess everything up. Now what I have to do is I have to understand the logic of this program. Um, so in your case, what you have to do is you have to when a push button is pressed, uh, the LED will turn on, and when it's released, the LED will turn off. Or let's put it this way: when the push button is pressed, the LED will be of one state, and when it's released, the LED will change its state. So first of all, let me create a circuit diagram for it in Proteus. So let's go in Proteus and let's create a circuit diagram, so you it's better for your understanding, so you guys understand it better. um, let me include all the parts I need. And the parts I need, uh, can you guys see this window? Zoom it a little. Okay, I'll do it for you. Zoom. How can I do zoom? I think it's more than visible, but it's, okay. I'll do zoom for you. How to do zoom? Is this enough for now? I think it's better now. So let me include all the parts I need. I need 89C51. I'll have to include it. So double clicking the part will include it in this portion, in this device portion. I'll double click it. It's already there. And similarly, I can also include a button. I'll have to enter button, button. Okay. As I've already told you that you have to search for the active library. This is the active library. Since I have to simulate it, I have to see it in real time, see it change in real time. So I have to click this part, which I have to include. I need an LED as well. I have to include an LED. So let's search LED. Let me go for a yellow LED since some of you guys were complaining. Let's go for red, or let's go for green. Okay. Uh, let me also include a resistor. I have to search for res, and this part is essentially going to be a passive element, since a resistor don't glow unless you burn it real well. You cook it, then it glows. Otherwise, it does not have any input. Like, it does not show you like if it's resisting or not. So I'll have to include this as well. And now I think I'm done with all the components. I can close this thing, this menu. uh, for closing, you can either hit OK, or you can either hit cross, or you can hit escape of your from your laptop. So now I'll place the components one by one. So the first one is obviously the controller. And what you can do over here is that you can connect everything, like every detail you can connect. You can even connect your the crystal oscillator. You can connect the push button for the reset circuit. You can do anything with it. So let me tell you how to do it, because obviously you'll have to do it when I'm not there, since I'm only here for some of your labs. Let's include a capacitor as well. Write cap in search and search for let's go for this thing, this passive, since a capacitor is could be an active element, but we only need a passive capacitor for now. I can include it, double click it, and it will be already included. So now I can hit escape. So what I need capacitor for is that since capacitor at starting of the circuit, it's already shorted, and the reset pin, whenever reset pin is high, the controller is it's gone to its reset state. And when the reset button is released, when it's low, the pin is low, then the controller starts from the beginning. The program starts from the beginning, from org00h. अब ये किसी को समझ नहीं आई, वो मुझे बताया ताकि मैं उसको अपनी लैंग्वेज में समझाऊं. Is this clear? Everybody got it, or there is someone left? नहीं, आपको क्लियर, आपको पता है कि आपने कैपेसिटर की यूज़ करना है रीसेट पिन की? मैं इसलिए बता रहा हूँ उर्दू में कि आपको समझ आ जाए। आपको जिसको समझ नहीं आती वो मुझे बताए। आप में से किसको नहीं पता कि हम कैपेसिटर क्यों यूज़ कर रहे हैं रीसेट पिन के साथ, और रीसेट पिन का क्या काम है इसमें? क्या किसी को पता है? Nobody knows. Okay. Let me tell you this the concept which is you know involved over here. So the reset pin. So let me first of all introduce you to active high and active low pins. So the thing is that first of all, let me zoom it in so you understand it better. Let me zoom it in. I hope it's done like this. Not do it the way I want it. Okay, I think now I can do it. Yeah, yeah. So essentially, active high pins are I'm doing it again. So essentially, what you have to what you have to keep in mind is what's active high and what's active low pins. What are those? So active low pins are the pins which have a bar on top. These this bar, the bar on EA, the bar on this pin, the INT1 and IT0, WR0, sorry, WR and RD. And if there is no bar on these pins, on just like the RST pins, then these pins are active high pins. And for them, what you have to do is that whenever the pin is connected to VCC or 5 volt, then the controller is resetted. The purpose will be fulfilled whenever the pin is supplied an active high signal. So what I have to do is that first of all I have to connect a capacitor to it. I'll introduce you to the concept what why I connected a capacitor over here. First of all, let me build a circuit. Let me place a supply over here, and the only component now left is a resistor. I'll place a resistor as well, and I'll connect it this way. You don't have to worry about connecting a capacitor and a resistor in this similar fashion. In Proteus, it's not, it will work without a capacitor and a resistor. So now I'll connect the ground portion. After connecting ground, now the circuit is complete, is nearly done. But let me change the capacitance as well. Let me do 100 nanofarad, which is I think it's zero point 0.1 microfarad or something like that. So what happens is that whenever I turn the circuit on, or I play the simulation, or even in real life, whenever you connect the circuit up to the supply, then what happens is that as soon as it's powered, the you know the 5 volt, the capacitor initially is shorted. In circuit analysis, you probably have read about the nature of the capacitor. Initially it's shorted for any signal, any supply to come. So the 5 volt will come over here, and the 5 volt signal will arrive in the reset pin, and initially, like, from the very beginning, it will be resetted. And after a while, when the capacitor gets charged through this resistor, after a while, this whole this controller will receive a zero signal, which is not of the same nature the RST pin works on. So the since RST is active high pin, whenever there is a high signal, the controller resets itself. So what happens is that when it receives a zero signal, then obviously the controller is in a different state, and it's working just like it's supposed to work. So this is a general circuit which sometimes you will have to build it for yourself, just to avoid accidental resets of the controller, or you'll probably see in the future, whenever you try to build some project with 89C51, that when you don't connect the circuit up, in your kits it's already there, but when in general circuits, when you don't connect the circuit up to the supply, and then obviously your controller is most of the time it's stuck, and it will not go, like it will not perform the the program as expected. It will be stuck in the beginning, and it won't move, it won't budge up even a little. So you have to connect the circuit, or you have to connect a push button. So when let me do the push button as well. You have to connect your push button just like this, in this configuration, uh, like this, so once this capacitor is charged, and there comes a time when you want to reset your controller manually, then you can hit this button, and it will reset it manually. So yeah, this was just a a simple circuit which I had to introduce you to. If only if you're working on a breadboard, then you have to build the circuit up by your hand, or manually. But if you're working on that kit, which I don't recommend, but if you got that kit, then it's already there, so you don't have to worry about it. Okay, so then now let's build our own circuit, which we have to do it which we have to do. So there were two pins, I guess. So let me recall the pins which I used. So for LED I used pin 1.5, and for push button I used pin 2.3, I think. Yeah. So let me go to the program and go sorry let me build the circuit up for this. For pin number 3 there is a push button, and for pin number 5 there is a you know an LED. So 2.3 we go with the push button, and what I'll do here is that I'll connect a resistor as well in this similar configuration, and I'll connect this up to the supply. We can also copy the component, so you can select the component, you can right click and block copy. So you can copy the component and you can place it somewhere else. In my case I want it here, and after it's placed I'll hit escape, and now I can connect this block to my button, and it's done. Let me check for the supply voltage. It's already there, it's 5 volt. And let me also copy this ground, selection, and then right click and copy block, and I can place the block right below this resistor and escape. So the copied section will be gone from your clipboard. um क्या अगेन भाई, महत भाई, क्या क्या अगेन बोलूं, मुझे बताएं. What do you want me to repeat? Sorry, I wasn't looking at the chat, so now you can tell me whatever you want to repeat. Mahad, you can tell me whatever you want me to repeat. LK Raider, I don't know who you are, but it's not a religious stream, so you can go somewhere else to do your preaching. I'll have to block you from this chat. You can go somewhere else. Mahat bhai, we are waiting for you. In the next few seconds, if you don't respond, then I'll go ahead. Okay, let's proceed. Since he is not responding, I think he probably is not online. So yeah, but I think it's better to carry on, since I think majority of you guys are just they're coming online just to text and then they're leaving. I don't know why, but um, it's very strange. Some of you guys are stuck. Trying to sabotage our stream. Okay, so this was a circuit which you have to build, and then obviously pin 1.5. I think that was a pin where you have to connect your resistor. So let me connect the resistor with the pin 1.5, and let me connect it. And now I'll connect my LED. Now the LED will go over here, and let me connect the ground, since already told you how to copy a block. So block copy, and then I'll move it here and escape. So now it's done. Now the circuit is complete. What you have to do now is that you have to make sure your resistor value you have. Okay, now it's clear. Great. uh yeah, for Farman Khan, you can type your question right away. I don't have to wait for me to see the chat. So yeah, you have to make sure that you have to select the right value of the resistors. In this case, what you have to do is that you have to change the resistor value for LED, because I've already told you the average value for LED resistor is 220 ohms. And if you guys want to learn more about how to connect the um, resistor for LED, you can look it up online, because the forward voltage for every LED is different. And based on the forward voltage, you can decide whether the LED is of white color, the LED is of green color, of like whichever color you want. You can decide it based on the forward voltage and the current. So based on the voltage and the current, you can decide it. But also you can there is a separate value of resistance for every LED. You have to select. uh, okay, for Man Khan, you're not you're not writing your question, so I'll probably go ahead with the circuit. So with push button, which with push button and with the resets circuit, you have to try different things, because obviously there's RC constant circuit involved. So you have to look it up, and do it yourself. Check whichever circuit works for you best. But in our case, I've already let's reduce the value. The first value was, I think it was much better, 1 nanofarad. uh, it charges a little bit faster than 100 nanofarad. And 10k resistor is just the general resistor which you have to connect. um, okay. 10k is a general resistor which we have to connect whenever we want to connect the push button. So now the circuit is ready. Now what we have to do is we have to write the program for it. I just did the circuit earlier, so that we have an idea of how it's going to work. So now let me get back to the keel terminal, and let's get into the programming. So after after the making up the circuit, what we have to do now is, let me first of all understand what we have to do in the case of the push button. Let me turn on the proteus again. So since the let me first of all play the simulation, and you'll be able to see everything in detail. So initially the every pin of the controller is in a reset state, in a high state, uh, unless you provide it with a signal. So what sorry, unless you provide it with a hex file, obviously, then the reset state will be gone. So what we'll have to do is that we have to, whenever we have to use a a push button, then we have to pull the pin low. The whole pin will be low at a 0 volt. So first of all, what I'll do is that I'll write this pin to low, you know. So let me clear it, clr, and let's clear this bit. So clr, uh, clr, and the pin is 2.3. So I'll have to do clr 2.3. Let me just go back to the, okay, I can do this. Okay, I wasn't able to do okay, this is sometimes it's tedious. Okay, let me clear clr p 2.3. I hope it's this is how it's done. So no, I think it's probably capital 2.3. Yeah, I think it doesn't matter whenever. If Oh, I haven't included. I haven't shown you the. So you can either write CLR P 2.3 or in capital or small. It doesn't matter in assembly language. In C language, it does matter, obviously, because the C language is case sensitive. So you have to worry about all the all the things you write. Uh, so now when I rebuild this project, so yeah, it works fine. Now let me include the file in Proteus. I'll just briefly show you how it affects the program. um, Go to the documents. Let me, where was the delete after stream? Yeah, this is the button hex, and let's change the frequency, which is 11.0592. I I I, I hope you can see it now. Still showing the old window. Let me include a new window. There is in the window involved, but it's still not showing that. Yeah, so here we go. So yeah, after setting up all the parameters, like changing the frequency and selecting your hex file, I'll hit OK and I'll hit play. So now you can see it will detect the state of the pin easily. When I push the push button, the state of the pin is changed to 0, sorry, to 1 whenever I push the push button. So and when I release it, obviously you get a 0 from it. Now I hope it's clear from this this demonstration how a push button operates and how to make it operational with a 8051, since 8051 is not having an input and or an output control system where you get to control everything from the pin state, sorry, the from the circuit inside the controller. uh, in other controllers, what we have is we get to have some of the um we have some of the resistors, um, some of the MOSFETs, essentially some of the MOSFETs which control the state of the pin. Whenever you want to use it as an input or as an output, it will automatically turn the internal circuit on, which has the circuit for pin as an input, and it will turn on whenever you want to use it as an output. But in 89C51, since it's more similar to 8051, it's not having the input output register or configuration or the internal circuit. So that's why we have to clear the bit first to make it operational. And let's get back to the programming mode. um, After clearing it, what you have to do is you have to get into the part where you can you can turn on or off the LED. So you have to write code for it. Let me write the code for it. So what I'll do here is that I'll set or clear the pin as well. Let me set setb p1.5, and I'll clear it as well, clr. But what I Sir, we can use the same program for other type of no, there's I've already told you about this thing. You have to, whenever the program is written in C language, then you can obviously use the same program, but you have to change the header. Only the header will be changed in case of C language. But whenever you're using assembly language, then you have to make sure that both of these controllers have the same assembly language. But um, in most of the cases, when the pins are the same, the registers are the same, then you can upload the hex file to the same controller. But since there are some commands which are not the same, then you cannot use the same assembly language program for the other controller. But in some cases the hex file will work. So you can upload the hex file, but you cannot use the same program in some cases. But in case of C language, you can use any of the any program for any controller. You just have to worry about the header file. So what I have to do is I have to clear and set the LD pin. Let's clear the pin first, just to look it up how it works. Let's set it. Oh, I've commented out the wrong, the wrong line. um, Let me rebuild the project, and let's go back to Proteus to see if it really works or not. Yeah. Okay. Yeah, so it turned off. So now my program is working fine. Let me get back to the business, and let me write the whole program for it. Let's get back to the business. Yeah. Okay. So what I want now is I want it to set the pin whenever there is an input. So what I'll do is I'll go for the command jump not bit. Since I'm working on a single bit, I want it to C for a single bit. Jump not bit P 2.3. Whenever there is no bit, a zero on bit number 3, 2.3, then I want it to go for another function. I want it to go to another loop. Uh, I'll do it the same way that I did in lab, but I kind of I think I forgot the names which I used in lab. But let me do it this way. Jump not bit. Um, Go to for off, and if it's bit, then come back here on, and sjmp. I think. Okay. I think I am done with the on part. Yeah, so let me write the same for the off part as well. So what will happen over here is that I'll have to now you make use of jump bit. Since I've already included the jump not bit, I'll have to create a function for jump bit. And after uh, using it for, let me write the program, then I'll speak, because it's kind of distracting sometimes. sjmp off. I think now it's completed. um yeah, I think now it's completed. So what will happen is that whenever I'll I'll search for jump not bit. If it's 0, then you'll have to go to for off and search whenever it's at 1. And when it's 1, then you have to go to 0 and search for whenever it's 0. So it's real simple, and there is nothing complex involved over here. So when the bit is 1, it will be, setting up the p1.5 as 1, and as soon as it's 0, it will fall back over here, and it will be stuck in this loop forever. When as soon as the pin turns to one signal again, then it will go back and it will be stuck over here. So this was the main logic which I think I designed it in a lab, but I forgot the program. So I've written it again, and let's see if it works. Oh, there is a syntax error at this line. Oh man, I hate these errors. So yeah, obviously, I forgot to include a comma here. Yeah. So I also get these errors. It's not big of a deal. Now let's rebuild it again, and everything works fine now. You know, it's really tiresome. Okay, let me redo it again so you guys see how I get to know the errors. So whenever you see an error, the error, there's a line number given over here. There's already a line number. Let me magnify it if I can, if it's visible. Is it visible? Is the error visible or not? Let me know in the comments. Is it visible? Okay, great. Great. It's visible. I have opened the magnifying glass anyways. Okay, I think the magnifying glass is not working with it. It's a Windows application, so that's why. So the fourth line, this is the error where there's already the line number given. So line number is 10. In line number 10, there is an error. So when as soon as I double click this line, the this error will go towards line number 10. It will point me to the error. It will take me to the error. Let me double click it. Double click, and now it took me to the error. So now I know where the error is. I'll include the comma, and we are good to go. Let me rebuild everything, and there's no error whatsoever. Let me go back to the circuit now, since it's already done. And when I play this thing, and voila, abracadabra. So it works fine now. So this is how you make your circuit work with the push button. Those who were following, they can they write W in chat. So I know those guys who were following and wrote the program, just you know wrote the program with me. I'm waiting for you guys to write W in chat, so I know you guys are following. Hurry up, make it quick. There are just two guys who are following for now. um, if you guys want if you guys want to see the program, then let me know. If you want to see the circuits, it's already there. The program is not that difficult. You can look it up anytime. It's I'll also paste the program in description. Let me write it in description. Let me copy it and write it in description. Okay. I'll include the program in and write it in description. uh, this is going to be difficult for me. Okay. I am writing this program in description. Please give me a minute. And here we go. Program AWS. embly program, and here we go. The program I've already included in description, so you can copy it at any time. It's already there. Um Only two guys are following. It's very strange. I've been, I've been helping you out with every need of yours, and only two guys are following me. Three guys. Okay, so that's all. Let's have, let me tell you the application of this led, and this push button. So what will happen is that, if you want to, create a circuit where, let's take the scenario when, when you want to, Dr. Gul has already assigned you an assignment, and in that assignment, I think it was an automatic door, or something like that. That, the door which opens automatically when you stand right beside, in front of it. Um, so, okay, Imran Arif is also following. Mahad Ellahi is also following. Yeah, that's great. That's great. So five guys have done, completed with the, the program. So, let's take the example of, when automatic. Let's take the example of automatic doors, and let me Google it for you guys. Automatic door. I got a real good example. So, let me download this thing, and automatic door using 81. Great, great, great. I got a good example. I'll show you guys now how to create your circuit, like for anything you want. There will be a circuit for it. So I've got some of the examples, like some of the images from online. Let me just download everything, so it would be easy for you guys to understand everything. Save it up. Let me download another image where you can see the, door, the physical door. I think it's decent, this picture. Yeah, so I got a decent picture now. Yeah, this one works just better. I think this one is fine. So let me download this one. It's much better. I'll save this image as well on the desktop, and I'll open this up. Both of these images will be open now. Okay, let me share the screen. Okay, in one image, this photo, and in the other image, there's going to be another photo. uh, and image. Yeah, there we go. It's much easier this way. Let me include it in desktop. So once, door system. Yeah. So let me let me first of all squeeze this and include another image. And this image is going to be, one is this, and image section. It's going to be this one. Yeah. Okay, great. I got both of these images, and let me tell you how to make everything operational. Since you've already got the, assignment, First of all, let me zoom this into the screen, and let me zoom this as well, and let's mm, let's adjust it for. Okay, great. So this image, yeah. So what happens is when you want to operate this door, you want to operate this door. There is a sensor on the front foot, in the middle. Whenever there is an input, let's consider this as a button, as a push button. So whenever you press this push button, this the same example. That's why the first and the second labs were important. So whenever you press this push button, there are a set of motors which activates towards inwards. So these motors are actually actuators which are activated towards the wall, inwards. And whenever there is a sensor over here as well. Let's consider this thing a button as well. Um, okay, so there was a text message which I had to respond to. um, okay, getting back to the business. So I was telling you guys how to make this thing operational. In our case, what we have to do is that we can install a button over here, consider a button over here, and whenever the button is pressed, then these motor pull everything, the gates inward. And there are a set of buttons over here as well. Whenever this door comes over here, it will press the button over here on another pin of the microcontroller. So let's consider this the foot button as the button which is connected to pin 1.0, and the buttons over here pin 1.1 and 1.2 over here. So when the door is opened, the button will be pressed from here and here as well. So 1.1 and 1.2 will be activated afterwards whenever the door is opened. And whenever pin 1.0 is activated, it means that there is a guy standing over here, who is pressing the button. And um okay, so the the door is opened in this case. And what happens is whenever the guy exits and the button is released again, then what happens is, since controller already knows that the door is opened fully, by this push button, since it's already pressed, then what happens is that once the guy leaves, the button is released again, and the controller knows that now it's time to deactivate the motors. So what happens is the motor gets to operate in reverse. So this way the door is closed again, and you can place a button, two buttons over here as well, to know if the the door is closed all the way. So this is the way you'll operate the door example. But in your case, you don't have to physically you use the push buttons for the doors. You just have to use one button which will open or close the motor, sorry, the door. You don't have to physically use the push buttons over here, and for the door opening and closing, for the direction of the open door and closed door. You just have to use one push button over here just to detect if there is a person standing in in the front, or he left. You just have to make some decision based on that. So when there's a person standing over here, you just have to move the motors backwards, and when the person leaves, you have to move the motor back in. Let me show you a module. Okay, first of all, let me show you the second image. It's also important. So there's this example. You see, there's this sensor, activation sensor there. It's already mentioned over here. So the activation sensor is placed over here in this image, but you can use an activation sensor on the floor. You don't have to place physical buttons. You can you cover the button, the top of the button, with a with a card, just to simulate that this is the activation pad. So when the activation pad is pressed, this actuator, the motor actuator, is pulled inwards, sorry, outwards. So what happens is that the door will be opened, and similarly when the push button is released, the door will be closed, because of the actuator will be pulled inwards. So this is how it will operate. Let me also tell you how, like, which the module which you'll use. It's called L298N motor driver. So this is the driver which you'll use. I'll download the image and I'll show it to you guys. Let me search for a good image, because let me open first of all the file which list of component for because that was the list which was having all the details. It was um, let me search for the list of component first, because I'll try to follow the same list which you guys got. It will be better for everyone, because obviously you have to perform the experiment afterwards. So let me open the list of components, and I hope I'll get to see all of the things over there. Let me open documents first. List of components. Yeah, I got that list, and let me open this thing with the Adobe, whatever that is, and share the screen. Sometimes it's real hard to work with the online stuff. Okay, I hope now it's now you can see my screen. uh, Bring it in middle. Yeah, so this was a list of components. And is my Wi-Fi gone, or your Wi-Fi gone? Mine is present. I think it was probably yours. So um, what you can do with this list is you can search for the motor driver. You can scroll down, come down, and so this was the thing I was talking about earlier, TTL converter. So this thing has a built-in transistor which you have to use. So this is the driver. You have to search for it. You can click and allow. It has already taken me to the 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 place where I can buy it. Let me download the image. The same thing you'll have at your end. Let me save the image and desktop, and this way I can let me just have a bit of modifications with it, and just remove the. Okay, now I'll include this image as well. Now let me close it and change the image, because I have already changed the image. Let me see for L298N. Okay, now this is the motor driver which you guys will use in well, when you're driving the motors. So what you'll do is that you can make use of this driver, and you've also got a circuit diagram over here, which you can consider. Let me zoom it in so you know how to make it operational. Okay, so here is the case. Here is the case when you want to use, there's a this driver could also be used as a stepper motor driver. I hope you guys are familiar with stepper motors, but this driver is specifically for, I have suggested you this driver for specifically for motor operation. If you want to control even the speed of the controller, the motor, or the direction of the motor, both of these will be controlled using this driver. So what happens is, to control the speed, you have to provide it with a PWM for on this pin, on the PWM pin. And the PWM pin is these four of the pins are PWM pins, so you have to provide PWM to these pins. And enable pins EN1 and EN2 pins are essentially the turning on and off for the motor. When you provide 1 and 0 to these motor, they the motor is turned on and off, based on the logic. So you have to google this IC, which is L298N, this IC, and you can look for the pinout. You can look for the data sheet and details of this, like how to make it operational. You can even try to get this IC out of this board and try to use it on a breadboard if you're working on a breadboard, so it will be easier for you. You can make use of it, um, and like in any method you want. So in your case, you can use one motor or two motors. It's totally up to you. Take a scenario where you can use one motor with it. So let's take M1 as a just one motor. So for this motor, you get to use these two pins, in one and in two. So for there are a couple of pins. Okay, so what you'll do is that you can, for M1 you get in 4 and in 3 these pins are used, and for M2 in 1 and in 2 pins are used. So what happens is, you'll when you try to reverse the direction of the motor, you'll have to uh, provide in 4 with a 1 signal, and in 3 as a 0 signal. So once you do that, the motor will be in rotating in, let's say, in clockwise direction, in clock direction. When you try to reverse this polarity, you'll have to provide in 4 with a 0 and in 3 with a 1. So this way the polarity will be changed, the direction of the motor will be changed. Yes, there is a question from Abdullah. मेरा प्रोटियस में रन नहीं कर रहा, सही क्या, कोड कैसे डालते हैं? I've already told you how to include the program. It's pretty basic. Right now I'm explaining this thing to you. I'll get back to it when I'm done with everything, since I am now explaining you how to operate, the assignment, how to do the assignment that you guys got. So with these reversal of directions, you can control this with the direction of the motor. So this thing is what you guys need. And the only thing that the information that you need to make it operational is to know how to change the polarity of pins, which you guys already know. It's based on clearing bit and setting bit. And the second thing which you need to understand is how to power things. So in this case, you can, for this motor, since it operates on 5 volt, you can provide 5 volt over here, and the motor will be operated. um, and the only thing left is now the push button. So you have to include a delay over here. So let's say the motor turns to the right direction, to clockwise direction for opening the door, and anti-clockwise direction for closing the door. Yeah. So in clockwise, when it rotates in clockwise direction, the door opens, and when in anti-clockwise direction, the door closes. So what you'll do is that you'll add a delay over here. Essentially it is going to be a delay which you can choose on your own. And let's say for 1 second when you rotate a motor, it in a clockwise direction, it will the door will be opened. And for 1 second again, if you rotate it in anti-clockwise direction, the door will be closed all the way. So you can make use of this logic, and you can turn on and off the pins of the motor driver, and you can simulate this thing. So it's pretty basic. It's just I just wanted to tell you how to make it operational. It's really easy. This is this example. So now let's get back to the business. Let me tell this guy how to upload the program. So what you have to do is, you have to, since all you have already created the hex file, you just have to double click this thing, and double click the controller, and let me turn on the window capture. And no, this not this thing. Yeah, this thing. So you double click the controller, and you'll get this thing. So over here you have to only select the frequency. You have to enter the frequency, and you have to um, select the file from here. I've already included the button hex in my program. I'll double click it, or hit open, and hit OK. That's all I'll have to do, and play afterwards. It works well. So is there any other question you want to ask? Is there any other question? I'll wait for a minute. If there is no question left, then we'll end the stream. Yes, this is my channel. Someone is asking me if this is my channel. Yes, this is a very old channel of mine. Yeah, I started it when I was in I was done with my bachelor's. Um, you can also watch my previous videos in this channel. So yeah, it's my old channel, really old. I never changed its name, so that's why. Um, yeah, so there I think we're done with the stream, since we don't have any questions. So I hope you have learned something, at least something from it, from this stream. I wish you all the best, and keep innovating. Thank you.